Hi and welcome to Geeks for Geeks. Can I have a quick +1 in the chat if I'm visible as well as equally audible? Till then, just let me turn on my preview screen. Okay, I'm fairly visible as well as equally audible. Okay. So it's 2:59. So we would wait for just 1 minute, and when it would be yeah, it's sharp 3 now. So let's start. Today we would be discussing yesterday's problem of the day, that is first negative integer in every window of size k. Okay, so this is quite self-explanatory name of the question, and this question appeared in Amazon, and this is an easy level problem, and the success percentage is very high, that is 54%. And let's see the problem statement now. So we are given an array of size n. Okay, so array of size n, this is the array, and size n 0, 1, 2, 3, 4 and 5, 4. Okay, and a positive integer k, this is the positive integer. Find the first negative integer for each and every window of size k. Okay, so it is seen that, suppose this is the window. What do I mean by this window something? So suppose I have the numbers as 0, 1, 2, 3, 4 and 5, and the window size is suppose 3, and the first window would be comprising of 0, 1, 2, and the next window would be 1, 2, 3, and the next window would be 2, 3, 4, and the next window would be 3, 4, 5. Okay, so this is quite clear. Okay, so now what is the first solution that you can think of? The first brute force solution that you can think of is that we can naively see all the windows of size 3. Like suppose we can take all the array of comprising of 0, 1, 2, and we can just compute our result. Okay, so that would be what? That would be this. And the next what we can do is we can again take this, and then we can again compute it. So you can see it. Now there is one more observation. Okay, what is this observation? Is that the first one is 0, 1, 2, 3, 0, 1, 2, and the next one is that 1, 2, 3. Okay, so you can see what is there. 0 outgoing हो रहा है and 3 incoming हो रहा है. Okay, fair enough. So ऐसा ही हो रहा है. So 0 is outgoing and 3 is incoming. So if you see a big size window also, if you see a window of size 2 also, you would observe the same pattern. This is the first window, this is the second window. The first window has an outgoing 0 at the next window and an incoming 2 at the next window. So can't we do something like this? Okay, so we can have something like this. Okay, let's draw a little bit smaller. Okay, and then we can do something like, first we would keep it here, then we would simply slide it. Okay, slide करने से 0 is getting outgoing and 2 is incoming. Then again the next 3 would come here and the 1 would go out, and this would be like this. Okay, and this would be again like this, and this would be again like this. So we can see that this is the idea. So what is this idea called? This idea is called sliding window technique. Okay, so slide. Okay, let's write it in a different page. Okay, sliding window. Okay, so what is the sliding window? We have we have like this, and we would simply pass on this. Fair enough. Now the question would arise when we would start thinking of the negative numbers. Okay, so suppose let us take this array only and we would compute it. Okay, so this seems good. What is the size? The size is 2 only. Okay, so let's draw like this, and then okay, yeah, fair enough. So this is like this. So first we would have minus 8 and 2. Which is the first negative? The first negative here is what? The first negative is minus 8. Then the next what we can do is we can have 2 and 3. Okay, so 2 and 3, which is the negative? No one is the negative, so the answer is 0. Then we have 3 and 6. Which one is the negative? 6 is the first negative, so we would write it. And then 6 is the first negative, we would write it. Simple thing. Okay, fair enough. So how can we do it? Okay, so what can we do is we can first insert this. Okay, insert this, and then at the next window we can remove it. But the problem would arise when we have a window like this, 2, 4, 5, then minus 7 and then 8. So you need to go on this whole window and drop here. Okay, fair enough. So whole window and drop here. मतलब वो क्या हो रहा है ना कि मुझे पूरा चल के बीच में आना पड़ रहा है, मतलब मुझे तो नेगेटिव खोजना है. Okay, मुझे तो नेगेटिव चाहिए. So I am just traveling all over the window and then I am spotting the negative. Okay, and then it would also have a time complexity of k, क्योंकि at max उसमें k ही elements हो सकता है. Okay, so ये spot करने वाला है time complexity k. Fair enough. Let's move forward. Now जो स्पॉट कर रहे हैं, जिसे हम पार कर रहे हैं, ओके, सपोज हम भीड़ से जा रहे हैं, अगर वो जिसके पार कर रहे हैं उनकी हमें नीड ही नहीं है, तो हम उन्हें हटा सकते हैं कि भाई आप हट जाओ, मैं सीधे चला जाऊंगा. फेयर इनफ. सो व्हाट आई एम ट्राइंग टू से इज, suppose I am in a busy road and there are some people standing which they have no work or they are not needed in the road. Okay, neither do have any work, they are just standing. Okay, so what I can do is, I can, instead of going to all the clearing the road here and there, I can just say the people who are not needed that yes, please go side, stand there and please make way. I can do that. So what, in the same way what I can do is, I can say that yes, 2, 3, 2, 4, 5, you are not needed because it is a positive number. We would never need it in our answer. It won't contribute anything to the answer, neither it would affect the answer. So I can simply say that yes, please go out and sit somewhere else. Fair enough. I got this idea. Now I don't need to spot or something. The first letter itself would be the first negative numbers. Now even if the window is having the elements like this, the first would be the first negative, this would be the second negative, this would be the second negative. Fair enough. So as we move forward, we just need to see if the first negative is of the last window or not, if the first negative is with the last window or not. Okay, so let's do a quick dry run of this and then we would start implementing, and we would again do a dry run so that it becomes crystal clear in our mind. Okay, and then we would discuss the data structure that we would be using to solve this. Fair enough. Now we would have a window of size 2 and positive are not needed because that are just blocking the view. So I would have, whatever be the data structure, I would have something like this. Okay, let's draw something like this. Okay, yeah, fair enough. So now first I would insert this 8 itself, okay, because it is a negative odd number and it would contribute to the answer. And this is the first window of size 2. So I have successfully iterated over this window and only this is the negative number, I put it. Now when this is complete, I would take out the first number, write it here as my answer, and then I would move forward. Okay, when I move forward, I would see to it that if that first character is outside my window or not. So we can see that yes, the first character is outside my window. So please kick it out. Okay, and then we would include the last character if it is negative. So 3 is not negative, we won't include it. So now the queue is empty. So if it is empty, so we can say that yes, the first we have a 0. So we can say that yes, it is 0. Then we would go to the next window. Okay, and then we would simply add the next one. What is the next one? Minus 6. Yes, it is negative. It would contribute to the answer. Okay, I enter 6, and then we would take out the first element, write it there. Then I would again move forward, and this 6 is not outside our window, so we can just keep it there. Okay, fair enough. And then we would say that yes, the first character is again the answer, and we would just again say it. Now what are the things that we require while doing this iteration? Okay, I hope this is clear, but I would still yeah, I would come to your Rohan D'Souza. Just wait for a second. Just let me say which data structure to use, then I would discuss it. Okay, fair enough. Now, what are the requirements of the things that we need? So we need to take hold of the first character. Okay, first character, first element. Sorry, not for character, first element, and then we need to pop from the front. So pop front. Okay, then we need to have what? We need to have push back, because we would be pushing elements from the back. Okay, then what are the things that we require? What are the things that we require? No, we don't require any more things. Fair enough. These are the three requirements. So whenever we need to pop from the front and push from the back, and something from whenever the both front and back are involved, we can only think of something like doubly ended queue, which is DQ in STL. Fair enough. Now we would use STL for this. Okay, fair enough. So let's see. Okay, so I would start a timer of 1 minute. Let me know if this is clear or not. Okay, so I would be waiting for just 1.5 minutes. If you're watching the recording, just move 1.5 minutes forward. Okay, we can store the indexes of negative number in n size array while traveling from right to left, and then for each index check whether is it present in the current. Will this work? Yeah, this would absolutely work. This would absolutely work. This is the correct solution, and I would be implementing this solution only. So Q will do then. Yeah, Q would do. Hey Supertech, how are you? Hey Chirag, how are you? Can you solve a question of a string? Actually, this is a POD stream. Okay, this is a POD stream. But what I can do is, after I complete this question, till I complete this question, suggest me a good question in the chat itself. I would be taking your question and I would be solving it live. Okay? Quickly do it. Quickly do it. Even if I don't solve the question completely, I would give you a brief idea of that. Just quickly do it. Any question you have in mind, just tell me. Okay, I see no more doubts coming in. So let's, yeah, so I've successfully waited for 1 minute, and let's go to the, okay, sorry. Okay, so let's start solving it. Okay, so what do we need to return? We need to return a vector of long. Okay, fair enough. So we would have a vector of long as answer, because here we would store the answer itself. Fair enough. So then we would need a DQ. Okay, so DQ of long, and I would name it as DQ. Simple. So then what I need to do is I am making everything lowercase, because I'm more accustomed to using with using lowercase. Yeah. Then I would have a pointer I is equals to 0. Then what I would do is, I'm at this position where there are two characters. So first I need to iterate on this whole thing. Okay, so first let us iterate on this whole string, and whatever is negative we would just store it. Okay, fair enough, seems cool. So for I is equals to 0, I is less than k, and I plus plus. Fair enough. And then what we would do is, if a of I is less than 0, we would push the index of it. Okay, push the index of it. Fair enough, we have successfully pushed it. And after this what we would do, first I was equals to 0, I is less than k. Now if I is not less than k, that means I is equals to k. That's why this loop broke. So now we have a point where the I is standing at this position, where the I is standing at this position, 0 1 2 3 4. So I is equal to k. K is what? 2. So 2 would be standing at this position. So this is how we make calculation. at which point to do what. When I was a beginner, I was having too much difficulty how they are doing so much calculations in their mind. So this is how we visualize the thing. Okay, so then what we would do is, for I, for this I is already there, so let's not waste time, and I is less than n and I plus plus, then we would move forward till the end of this. Okay, so now what we would do is, first we would take out the value, just the front value. So what we would do is, if dq is not empty, okay, so if dq dot empty, so if the dq is having empty, that means we don't have any negative characters, negative elements, so we would just insert a 0. So answer dot push back 0 itself. Okay, fair enough. Else what we would do is, answer dot push back, okay, answer dot push back a dash dq dot front. This means that there exists an element. Okay, fair enough. Now we would move forward. So now we would move forward, and the next thing what we need to do is, we need to include this point. We need to include this point. But we would only include this point if it is negative, because I said that when it is negative, include it. Else वो काम के नहीं है. Okay. So what we can do is, if a dash I is less than 0, we would include it. dq dot push back, okay, I itself. Fair enough. Now what we need to do is, before pushing, now I have successfully pushed it back. Now what I need to do is, I need to take out the elements from this side. Okay, so now my I is at this position, okay, the position that is marked, and I need to remove this one. Okay, what is the index of that? Index of that is equals to I, so this is 2 and less than equal to, so I need to remove this point. What is this? The current index, if it is 2, 2 minus 2 would be 0. So we need to go till it is 2. Okay, fair enough. So whenever you access the front element, don't access it directly, because अगर front element ना हुआ और तुम front element access करने लगे, you would get a segmentation fault. You might not get it because it depends on the compiler, but most of the time you would be getting it. Even if you don't get it, you would get an unexpected result. Fair enough. So while dq is not equal to empty, while dq is not equal to empty, what we can do is, while dq is not equal to empty, and dq dot front is less than equal to I minus k itself. Okay, what we would do is, dq dot pop front. Okay, fair enough. So then what we would do is, we would move forward. At the end ये जो element है, we are pushing it here, so it would come here, then it would come here, then it would come here. So last वाला तो process नहीं हो रहा है. So what we need to do is, we just need to copy this again, that if it is last element is greater than 0, then we would simply push it, else we would be moving forward. Fair enough. So let's see. So I is equal less than 0, we would push it if it is useful enough. So if dq dot empty is, if it is empty, then we would push back 0, else we would push out the front element. And then while it is less than I minus equal to k, that is pop front. And then if it is less than, if it is useful, insert it, else just ignore it. And then what we need to do is, if the dq is empty at the last position, we would do it. And then what we need to do is return the answer vector. Fair enough. Let's see if this is correct. This is giving correct answer for the sample test cases or not. Okay, so I used this one, so that would be pushback. 8066, yeah, fair enough. Yeah, so this is solved successfully. If you have any queries, quickly tell me, and I would start seeing the question that is sent to me. Okay, so 1.5, okay, that would be 1 minute. Okay, let's see the question. Okay, yeah, Q would do this purpose, and to be honest, Q is the most appropriate data structure that we should use. But I don't like to think so much. Just आगे पीछे जहाँ आया, I like to use DQ. Fair enough. Okay, so thank you. Can you solve? Yeah, I would do it. Most welcome. Okay, given a string, write a logic to return the longest segment in S with equal number of case sensitive vowels and constant. Okay, yeah, this is very easy. It's confusing. Please dry run once. Okay, I would do it. Just let me read the question and I would explain it to you. Okay, so implementing this would take a lot of just 20 to 25 minutes, and the string would be extended to a lot. But still, I would be giving you an idea after I do the dry run. Okay, so let's do the dry run. Okay, I would be giving you an idea. This question is very interesting, to be honest. Okay, so let's take the first example itself. Okay, so चलिए first example लेते हैं. Okay, so let's just copy the test cases and then we can move it to the solution. Okay, what is happening? Let's see. Yeah, it's very confusing. Okay, let's see. Okay, so what we need to do is, first we are just inserting all the negative elements. So यहाँ तक गए. Okay, so negative elements insert कर दो. We now have -8. Okay, because it is just the negative. Why positive elements are not included? Because they are just hindering the process of finding and all. So अगर positive elements हटा दो, that would be very easy. Okay, अभी answer यहाँ पे कुछ नहीं है. Fair enough. And then after that, I would be at this position. I would be at this position. Okay, this is I at this position. So we need to include this position and exclude this position. Include that, exclude that. How we would do it? But before doing it, जो यहाँ पे है, we need to process it. Okay. So what is the front element? There is some element. Yeah, there is some element. So we would just write it here itself. And then what we are doing is, if we are removing the front element, okay, I minus k is less than equal to I minus k, we are popping it. So now this would get popped out. Fair enough. हो गया. Now if this is to be included, but I would include that only if it is negative. So अगर ये negative है, no, it is not negative, so we would simply ignore it. Okay, and then after doing all this and then this, then this, then this, okay, तो ये वाला include तो किया, but इसका answer कहाँ है? But इसका answer निकल कहाँ रहा? Okay, that is why I am doing it explicitly. So एक explicitly हो गया. Okay, so Chirag Goel, just confirm if you have understood or not, and then let's start doing it. Okay, the question that you are trying to ask is, would be solved using 2-pointer. Okay, how it would be solved using 2-pointer? So this is the thing, that given a string S, okay, given a string S, what you need to do is, you need to return longest segment with S in equal number of case sensitive vowels and constant. Okay, so vowels and constant. So what you need to do is, you need to have a tail pointer. Okay, tail pointer with -1 and head is equals to 0. And what you need to do is, you need to keep moving forward. You need to keep moving forward till tails and heads are same. Okay, till tails and heads are same. And then जहाँ पे जाके वो head रुकेगा, take the maximum, keep it. Okay, फिर tail को कम करो. Tail को कम किया एक, tail को कम किया एक, फिर head को बढ़ाओ. Okay, फिर tail को एक और कम किया. जहाँ तक head बढ़े बढ़ाते जाओ. फिर tail को एक कम कर दिया. फिर हेड जहां तक बढ़े बढ़ने दो. फिर टेल को एक और कम किया, जहां तक बढ़ रहा बढ़ने दो. फिर टेल को एक और कम किया, जहां तक बढ़ रहा बढ़ने दो. वी वुड डू द सेम प्रोसीड्योर, एंड एक जगह ऐसा आएगा जहां पे हेड रुक जाएगा लास्ट में जाके. एंड देन वी वुड अगेन कंसिडर दिस. यहाँ पे बढ़ा, यहाँ पे देखा, यहाँ पे देखा, यहाँ पे देखा. एंड ईच पॉइंट बस इतना चेक करना है कि इफ द नंबर ऑफ वॉवेल्स is equal to the number of constants or not. If that is, compare it with the answer that is already there, global answer, the answer variable. Just take the max of it. Okay, fair enough. This was just the idea, and writing the while loop and all that would just take time, that is why. So super tech, did you understand or not? Even if you don't understand, just text me on LinkedIn. My username is Siddharth. Okay, I would be more than happy to explain you. So that's all for today. Thank you and have a nice day. I would still wait for one more minute to see if this is clear or not. Okay, Chirag Goyal, I'm still waiting for your reply. Hope you reply. Okay. Okay, so there are only 2 people at the moment. Okay, so that's it for today. Thank you. And okay, just read about 2 pointers and you would do it. Tail and head is just an abbreviation to take the pointers. Okay, fair enough. So that is it for today. Sir, can I get your ID? Yeah, my LinkedIn ID is Siddharth. Just search Siddharth Hazra. So SIDDH. Okay, just yeah. Type this name that is there. Type this name in the LinkedIn and you would get it. Okay. So that's it for today. Thank you and have a nice day. Still, if you have any doubts, you can ask in the comment section. And that's it. If you have some time and if you think that feedback should be given, you can either criticize me or praise me. Thank you. Have a nice day.